So we have a linked list created here and we have a node.java file, but I want to solve a particular problem that could be asked in coding interviews, and it's pretty important. Problem is finding the middle node of a linked list. Like in my previous video, I used 2 pointers moving in parallel to solve the array nth list problem, right? Which was over here solved. But now I can't use that. There's no benefit of using 2 pointers moving in parallel for this. Now the problem is finding the middle node of a linked list. Suppose this is the middle element or the middle node and I want to find it. Now I know that I only could start from the head, and this is just a basic implementation here, but this could map out to any number of nodes in a list. We know that it's possible to find a solution by iterating through the entire list, creating an array representation, and then returning the middle index. We could potentially take up lots of extra space. Here we have an array list. I'm just going to call it an AL. And we could just copy the entire content, which is over here, size, and divide it by 2. And you could just get the middle element from here. So you could just say array length and divide by 2. And it's good. It's a good solution. But the same thing is that it's memory expensive. Instead, we can use 2 pointers to move through the list. The first pointer takes 2 steps through the list for every 1 step that the second takes. So it iterates twice as fast. So let's say we have a fast pointer and I call it F, and it's over here actually in the beginning. And we also have the slow pointer, and that's the S, and that's also moving here, right? So the fast pointer will always move 2 steps forward, and the slow pointer will move 1 step forward in every iteration. This is the condition that we will check 2 times. So it'll go 1 step. If it's satisfied over here because it's pointing to the head, it will go here. And then it will check again if it's not equal to null. And if it is, then it will go 1 more step. So since the fast pointer moves 1 more step, the second pointer will move from here to here, just 1 step. And then again, the condition will be checked. If fast not equal to null, move again 1 more step. Now, actually it is pointing to null. So the second condition won't execute because it's not null. So we'll just actually return the slow pointer, which is the S1. And there you go. The slow pointer is currently pointing to the second last. And that's actually the middle node. So that's our solution here, and let's go to the code. In the code we have a static node, find middle. We pass in the linked list that we're using. So we create a fast node pointer that points to the head, and we also have a slow node pointer that points to the head. Now let's put the conditional. So we have a fast pointer that points to the head. The slow pointer also points to the head. Adding a conditional here, that fast not equal to null. So while fast not equal to null, fast is going to move 1 step forward, and then we add in another conditional. When fast not equal to null, fast moves another step forward while the slow steps 1 time. And then after that, once we iterate the entire thing, we just actually have to return the slow. Over here we just return slow, and that's our middle node. So that's our solution. Now let's discuss the time and space complexity to this solution. As with the nth to last solution in the last video, this solution also has an O of n time complexity because we're moving through the entire list. Over here you can see this while loop actually demonstrates that. The space complexity is also O of n space because we're using just 2 variables, just node and node fast and node slow. And an alternative solution to this problem is called half speed. It's equally valid, and the idea here is to move the fast pointer once with each loop iteration, but only move the slow pointer after every other iteration. So we're going to check if fast not equal to null. That condition should be applied here. And if it is, we're going to move the fast pointer once here. And then we're going to actually ask a conditional here with a counter. If that counter, we're going to specify. So we actually pass in a conditional that you will see in the code that will look if the number is odd. If the number of iteration is odd, then we will move the slow pointer once. And if the number of iteration is even, we'll just leave it as wherever it is. So for now, we know that the counter is 0, so it will just remain as it is. And in the second iteration, when it's 1, this fast pointer will move again 1 step by looking at the conditional if it's not null. And then the second pointer will move because now the iteration is 1, which is odd, so the slow pointer will move 1 step. And this is how we're going to solve it. Let's look at the code here. So this is the find middle alternative solution. We're using a counter. Now, the additional part here is that we're using a counter to check our iterations. We have a fast and slow node, and they're both pointing to the head. Now, the conditional here is while fast not equal to null, fast is going to move one step forward, and if it's not divisible by 0, so we're going to have to move slow one step whenever it's an odd iteration. So count plus plus is just going to increment until the whole thing is done. After that, you just return the slow pointer, and that will be your middle node. So many linked list problems can be solved with the 2-pointer technique. If it seems like a linked list problem requires keeping track of multiple positions or creating other data representations such as an array or an array list, consider whether 2 pointers iterating in parallel or at different speeds could help solve the problem efficiently. Now, I have a task for you guys. I want you guys to understand what we learned in this video and then try to apply it in these 2 different scenarios which I'm going to be discussing right now. So the first scenario is try to use the 2-pointer technique to detect a cycle in a linked list. If you could do this, then write the code in the comments, and I'll be looking forward to checking your comments. And also, the other problem is to rotate a linked list by k places. Thank you for watching this video, and I hope I see you guys very soon. Peace out.